All right, Algebra 1, Lesson 60. I believe this starts over on page 390 in your book. I'm going to talk about finding special products of binomials. So these are special situations, which means when you see these situations, the same patterns will be consistent. Okay, so a lot of this is meant to save you time, but it takes some practice to recognize these things. Okay. All right. So the square of a binomial is your example here is a plus b squared. It could be x plus y squared or p plus q squared or x plus 3 squared, something to that nature. Does that make sense? Or the subtraction of that, so something like x minus 3 squared, results in what we call a perfect square trinomial. Trinomials are the form that look like this, except better written, so something like a squared plus 2ab plus b squared. Really, a lot of this, what this is about is patterns and noticing patterns. Okay, so this is what we would get with the a plus b squared. Okay, we'd get a pattern that looks like a squared plus 2ab plus b squared when we're taking a plus b times a plus b. Because hopefully we understand by this point that a plus b squared is not a squared plus b squared, right? That we have to FOIL, we're multiplying the whole binomial by that whole binomial. We follow me so far? And by doing that, we're going to FOIL. So whenever we see this, we need to think FOIL. All right, for the second part, where we have something like a minus b squared, okay, we would get something that looks like this. I'll fix it so we see a squared minus 2ab plus b squared. The reason we have a plus b squared at the end is because a negative b times a negative b is a positive b squared. All right, so it's going to be negative positive. Does all this make sense so far? Okay, these are what we call perfect square trinomials because they're the product of a factor times itself. All right, the product of a sum and difference of two binomials, all right, is where we see something times the same thing but with the opposite sign. This is what we call a sum difference. Okay, so a sum difference is going to simplify to something that's going to look a little bit more like a squared minus b squared. You'll notice that there's not that middle term, right? That it's not a trinomial. And the reason it's not a trinomial is because those middle two terms end up canceling out. Anytime I have a sum difference, I'm multiplying, say, x minus 3 times x plus 3. Let me just show you. If I'm taking something like x minus 3 times x plus 3, okay, this is a sum difference, or it's some difference. It's the same thing. The only difference is the signs. All right. In my FOIL, x times x is x squared, right? Then I'm doing x times 3, which is positive 3x. I'm doing negative 3 times x, which is negative 3x. I'm doing negative 3 times positive 3, and I'm getting negative 9. And whenever I simplify that, what do you notice? What happens to the 3x's? They cancel. So if it's a sum difference like this, the middle two terms will always cancel, okay, because they're going to be opposites of each other. So here I wind up with something that looks like x squared minus 9, okay? You're not going to be done with this, all right? This doesn't go away after this lesson. We see this, the better that you understand this, the better that you're going to be in Algebra 2 and Algebra 3. Okay? You're getting introduced to this now. The more successful you are here, you'll be wildly more successful there. Okay? All right. So where you see x squared minus 9, the pattern is a squared minus b squared. Have I lost anybody up to this point? Okay, great. All right. Special product of binomials, so we have square of a binomial, which is somewhat what we just saw. What you're seeing here and here is what we just showed on the last page. over here on the example side are just what that's going to look like. So x plus 5 squared, we would work that out by doing x plus 5 times x plus 5. Okay? What we get is x times x is x squared. Then we're getting x times 5, which is 5x. Then we're getting 5 times x, which is 5x. What's 5x and 5x? 10x, so we're able to combine like terms and get 10x. And what's 5 times 5? 25. So do we understand how that example works when we're taking x plus 5 squared? Okay, great. Let's see, with 2x minus 4 squared. Okay, so we have some subtraction here. That's 2x minus 4 times 2x minus 4. What's the first two things I multiply? Remember FOIL, first, outer, inner, last. What's the first things I multiply? Jordan? What's 2x times 2x? 4x squared, which you see right there. Okay, so that does that. All right, what's the next things I multiply? Caden?
4x and the negative 4.
Those would actually, you said the 4x? The 2x and the negative 4. What's 2x times negative 4? Negative 8x. All right, so you're right there. What's next? Christian? We did first, and then we did outer. What's next? FOIL, F-O, what's the next letter? Inner. Okay, I, inner. Okay, what are my inner two terms? Okay, what's negative 4 times 2x? Negative 8x. Okay, and this symbol is messed up here. That should just be a minus instead of an equal sign, so sorry for that. Okay, so we got 4x squared minus 8x minus 8x. Okay, what's next, Tiffany? What's negative 4 times negative 4? Positive 16. Do we see how that reduces to 4x squared? We combine like terms, we get negative 16x plus 16. Okay? So it's still just foiling, right? Even if I didn't see the pattern, could I still foil? Yes. Okay, so we can always fall back if we don't just necessarily have this information downloaded into our brains yet. Okay? All right, so these are just basic squares of basic sum and difference binomials. Now if we do sum and difference, okay, we looked at something like this over here on the last page. Let's look at 3x minus 2 times 3x plus 2. Abby, what's the first thing that you multiply here? What's 3x times 3x? 9x? Are you sure? Something might be missing there. What's x times x? X squared. So we need our x squared. What's up next, Mia? The outer, okay, which is what? 3x and 2, which is, okay, positive 6x. All right, what's after that, Jeremy? Inner, which is what? Negative 2 and 3x. What's negative 2 times 3x? Negative 6x. All right, Reagan, what's next? Negative 2 times 2, which is negative 4. Okay? Let's see, Blayton. If I want to simplify that. Combine like terms. What are my like terms? So what happens there? It just cancels out. 6x and negative 6x just cancels out, and I'm left with 9x squared minus 4. This is what I want you to notice about these two terms. They will always be a perfect square minus a perfect square. A sum difference will always result in a perfect square minus another perfect square. Okay? Which means if I recognize that pattern, then I should be able to go back the other direction. Okay? And I know that the square root of 9 is 3. I know that the square root of 4 is 2. So that I could actually write that up I should get 3x minus 2 times 3x plus 4. Right? I could even solve for x at that point, and that's a little bit beyond what we're ready to do today. Okay? All right, since we don't have a lot of time to do a whole bunch of practice questions, why don't you look at your homework assignment and let's pick one or two out that we can do together. Anything that pops out to us? Page 393, I think, is where your homework picks up from. Okay, all right, well, I'm going to hit stop on the video then. I think you guys got it. Oh, they're all pretty easy, it seems like. Great. Okay, we'll hit stop there then.